So we've got the integral of x cubed plus x divided by x minus 1. First thing I notice about this is the numerator degree is larger than the denominator degree. So I'm going to use long division here. So since the top degree is a degree 3 and it's greater than the bottom degree, which is a degree 1, then I use long division. Now, long division, I have x minus 1 divided into x cubed plus x. And so I multiply x squared by x minus 1 to get x cubed minus x. And so I'm going to write my x squared up top here, draw a line, change the sign. And so this cancels here, but this gets me 2x here. So how many times will x minus 1 go into 2x? If I multiply by 2, I'm going to get 2x minus 1. And so I have 2x minus 1 here. And that's going to get me draw the line, change the sign, cancel here, but I get a plus 1 here. So I have a remainder of 1. So that gives me 1 over x minus 1. When I have that remainder, I put the divisor in the denominator there. Okay? So this simplifies the problem a little bit. Now I have the integral of x squared plus 2x plus 1 over x minus 1 dx. I'm going to divide and conquer this thing. I have integral x squared dx plus integral of 2 dx plus the integral of 1 over x minus 1 dx. This is x cubed over 3. This one is 2x. And then this one, u substitution, pretty straightforward. du is dx. And so this is integral 1 over u du, which we know to be ln absolute value of u, but u is x minus 1, so it's ln absolute value x minus 1 plus c. And so this is my answer right here to that problem. So we took a pretty complicated problem here and we turned it into an easy problem through long division. Remember, if the numerator degree is greater than or equal to the denominator degree, then I use long division to simplify first. Okay? And then once you do that, you can use partial fractions if necessary. All right, so one more partial fractions problem. And I know I'm going to use partial fractions here because the numerator degree is less than the denominator degree. Okay, so x cubed plus 4x dx. Now, first thing I'm going to do is factor the denominator. Whenever I factor, I pull an x out, I get x squared plus 4 in there, dx, and I have 2x squared minus x plus 4 in the numerator. Now, I cannot factor this anymore to sum of squares, so for real numbers, we're done, okay? So I have an irreducible, so 2x squared minus x plus 4, and a linear factor. So irreducible and a linear factor. So that means I'm going to have an a over x plus a bx plus c over x squared plus 4. And whenever I multiply through, I'm going to multiply through by x times x squared plus 4. Whenever I do that, I'll get 2x squared minus x plus 4 on the left. The denominator cancels everything. Here, the x's will cancel, which will leave me with a and then x squared plus 4. And then here, the x squared plus 4 factor will cancel and leave me with the bx plus c times x factor. And at this point here, I'm just going to distribute through. And so I get ax squared plus 4a plus bx squared plus cx. So this is ax squared plus bx squared plus cx plus 4a. So if I factor the x squared out of here, I have a plus b x squared plus cx plus 4a equal to 2x squared minus x plus 4. I'm going to put minus 1x for purpose. So my 2 needs to equal a plus b. My negative 1 needs to equal c. And then my 4 needs to equal 4a. Well, that's helpful because 2 equal to a plus b is not bad, but negative 1 equal to c is really easy. That's the answer, right? And then 4 equal to 4a, that tells me that a is going to be 1. If a is 1, then that means 2 equals 1 plus b, so b has got to be 1. Okay? So a, b are 1, c is negative 1, and I'm ready to rock and roll. So I have 1 over x plus, now b was 1, x, and then plus c is negative 1. Okay, over x squared plus 4. So this becomes the integral 1 over x plus x minus 1 over x squared plus 4 dx. Okay. So at this point, I'm going to break this up even further. Remember, if you have a fraction with a numerator here, I can break this up like if I had a plus b over c. This is equal to a over c plus b over c. Okay? So this is integral 1 over x dx plus integral x over x squared plus 4 dx, and then minus the integral 1 over x squared plus 4 dx. Okay, so I split this up into two different integrals here. All right. Integral here, not too bad. That's ln absolute value x. This one is a u substitution. U equals x squared plus 4. Du is 2x dx. I see an x dx, so I'm going to divide by 2. So 1/2 du equals dx tells me, or x dx rather, and so that gets me 1/2 du over u. So that gets me 1/2 ln absolute value of u, which happens to be x squared plus 2, or plus 4. And then this last one here, if you see, you've got your integral trick here. You see that this is a square and this is a square, and it's a sum in the denominator. It's actually 2 squared for 4. You can use your rule that this is the arctangent of x over a and 1 over a here plus c, where a is this number right here. So if you wanted to jump straight to that, I would be okay with that. If I tell you to show me all work for the algebra, what I'm really looking for is for you to be able to factor this 4 out here. And I have x squared over 4 plus 1. And so that's negative 1/4 on the outside, 1 over. And then in parentheses, I have something squared, right? Well, how do I make this a something squared? I'm going to make that x over 2 in there. Okay, and then that kind of does what I'm wanting to do there. Okay, so then I do a v substitution, x over 2. dv is 1/2 dx, multiplied by 2 to cancel out the half there. And so that 2 multiplies in here, so I have negative 2 over 4 on the outside. Integral 1 over v squared plus 1 dv. I know that this is arctangent of v, and I have the negative 1 out half, and then this here gets me the x over 2 that I was looking for, just like that x over a scenario. So putting this all together, what do I have? I have ln x plus 1/2 ln absolute value x squared plus 4 minus 1/2 arctangent of x over 2 plus c. And that's where we are. All right, so hopefully this makes a little bit more sense to you. Sometimes you have problems that are a little tricky, and this one will help you out with a homework or a test question. This one looks like it could be something else, maybe a trig substitution problem, but it turns out you can rewrite this using partial fractions. If you let u equal the square root of x minus 1, how could I rewrite this to be in terms of x equals something? Well, square both sides, u squared equals x minus 1, and then add 1. And so I have u squared plus 1 equals x. So I'm going to replace x with u squared plus 1. And I'm going to replace this square root x minus 1 with u. So now all of a sudden we've got a u substitution problem going on there. Okay? So kind of a interesting thing happening there. And you'd have an a over u plus, because this is a linear factor, and then this one is a irreducible quadratic, so it's a bx plus c over u squared plus 1 factor going on there. And you could run through the algebra to figure out what a and b are. Okie dokie. Good luck with your partial fractions and your all your other integration techniques that you now know. You've got u substitution, you've got integration by parts, partial fractions, trig u substitution, and then trig triangle identity trigonometry. Remember that trig dictionary where we did substitution through that too. All right, guys, good luck.